it's not enough if this machine is energy efficient, the Huddig that I have behind me, or the Gripen. These machines need to be energy efficient together, and everything needs to gel all the way up to the power lines. Everything needs to be efficient for there to be enough energy to go around. And the way we can do this is by digitizing and having machines talk to each other. And what we're doing here is putting sensors on the Gripen. As far as I know, the first time we do that. And we don't have any wires to these sensors, which is super important in this machine, because a Gripen usually is in a very harsh environment. And if you have wired sensors, things can break. So this is a very important step. And also energy harvesting, because if you have a sensor that doesn't need a battery replacement, it makes everything a lot easier. So that's what we're going to demonstrate. We're going to hear more about the technology in a bit. What we're doing here today as well is almost a demonstration of a test bed, of what a test bed can do. And I think it's very, very good and important that we have representatives from industry, from academia, we have representatives from the Research Institute RISE, and from public office. Because if you look at this model, I'm not going to go into lengths into this model, but what we're doing here is a transformation, a very difficult transformation, where we're actually throwing out oil. And we've been dependent on oil for 100 years. This is a massive shift within industry. And we can't do that. Hiab can't do it alone. Huddig can't do it alone. Scania isn't big enough to do it alone. There's not a single industry that can do this transformation by itself. The only way we can do this is by having industry talking to public institutions, because this is also part of policy. Like, how do we build power lines? How do we make sure that there's energy enough to feed the hospital in Gävle, for instance? All these things need to coexist. And then we have academia. As far as I see it, when we have described this testbed, what it's supposed to do, we have academia surrounding all of this to help us interpret what we're doing, and also come with suggestions and provide us with the specialist competence that we're going to need to be able to do this transition. And the whole point of this is to be able to make radical decisions. And why radical decisions? Because we're very short on time. Hiab, for instance, has signed up for the 1.5-degree target. We're just a few years away, and it's a very difficult target to meet, and we need to be able to act fast. So that's why this is so important, that we're academia, research institutes, public institutions, and business industry here.
So what you see on screen here is a bar showing the accelerometer for X, Y, and Z. So hopefully, when a driver does something rough here, you will see one of the bars get up, get down.
So what we can see here, that's the spikes for when the claws were smashed together. And that was kind of the initial problem that Gripen wanted to see, because this is something that is potentially harmful to the Gripen.
First of all, when you go max and mean of the claws of the Gripen, you do this clonk, which we call it. It's damaging the Gripen. That we can prevent, and also the maximum clonk we can also prevent by having the sensors telling that we are closing into the maximum points. And when Sigge was lifting the logs here, we all hear the crushing, this crunch sound. And that is when the Gripen using too much power to actually lift the logs. So we don't need that kind of power. So if you have a sensor on the piston saying that, oh, the pistons are not moving anymore, then we can send data to the Tigon saying that you don't need to push more hydraulic pressure. You can stop here. And then you have enough power to actually lift the logs and saving a lot of energy.
If we have an energy efficient machine and the tools are not so energy efficient, we will lose efficiency on that end. So we need to have the whole picture needs to be energy efficient. And the way we do it now is we can help each other to see what kind of modifications do we need to do in the future to make this a total product for the user.
We can't carry that much of energy, just like the Huddig, and we will have the exact same problem. Our user doesn't care if he run out of energy. he will probably blame us. We will have a very hard time blaming someone else, saying that the attachment of the machine is bad and so on. So therefore, we need to kind of know how much energy that goes back and forth on a crane, on an attachment. And it also, wireless sensors with energy harvesting opens up a lot of possibilities in the way of positioning, doing other stuff with the tool.
Yeah, it's same thing, saving energy. We can make lighter designs that will be less heavy, that will also save energy for the machinery or the equipment it's connected to. So yeah, it's really important for the future, I think.